Kevin Kurtz. I'm the VP of Engineering for Quadrant Solutions, and we're going to talk about haptic motors. What is a haptic motor? It's an actual little motor device that is creating some sort of force feedback for a user. So it's vibrating or moving in some way to give you some sort of feeling based out of your digital device. So if your device says that, hey, you need to be alert, or hey, there's something happening in front of you, in real life, if you run into a wall, you're going to feel that. Your digital device can't really tell you that in a certain way. So we use these haptic motors for user force feel so that the user knows something's going on. They've been vibrating for a very long time. We used to have beepers that would vibrate and tell you, hey, you're getting a message, a silent way of triggering something. But now they're a lot more advanced. We can run at a lot of different frequencies to give you different force feels. Let's say I press the screen a certain amount, I give it a certain amount of force. That force feedback might vibrate a little bit. I press harder, it vibrates harder. This is the tactile feel that you need to interact with our digital world. So what's happening there is we've got something that's going to vibrate. It's either a spinning mass that's beating against the side of a motor shaft, or we've got a tray that's going to beat against the walls as it goes with spring feedback back and forth. That's called a linear resonant actuator. That's done in most of consumer electronics now. It's going to be a magnetic tray or a magnet on a tungsten tray that's going to be activated by a coil and pushed back and forth into the walls at a certain frequency. The higher the frequency, the less you're actually going to feel it. The higher the density of the tray, the more force that is provided, momentum back and forth against the sides of the actuator, providing that vibration feedback. So we want a high density object in there, as much magnetic force as we can get to push it. That gives us options from a really low feeling force feedback at a small frequency, or a high force feedback at a high frequency, because usually those two are mutually exclusive. The higher the frequency, the lower amount of energy transfer that you're feeling back and forth. So we can actually tune these to different frequencies, different feels, and then use a different driver configuration to try to meet your force feedback. Do you want this to vibrate hard a couple times, burp, 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 or do you want really fast so that the user knows something else is going on? So let's say we're building up a signal, we're speeding up a car in a video game, you're gonna feel that low RPM versus the high RPM, all from one motor situation. And this is to allow the user to interact with the phone, allow the phone to provide some sort of feedback. This is done in tablets, video game controllers, anything else that a user might need to interact with that's typically a solid state device. We can custom engineer these haptic motors to your power needs, your performance requirements, and mass production needs. We can do custom motor designs to meet your needs. We have different power requirements, different size, strengths, anything that you need to modify within these designs. We have engineers standing by ready to help you design and meet your exact application, and then we can ramp up to mass production. Large quantities are not a problem. Sample quantity is just as easy.